Find the reading of the spring balance as shown in the figure. Assume mass is in equilibrium. Now mass m is in equilibrium, it makes this sum very easy. Now mg will be in the downward direction. There will be a normal force in the upward direction. Let this normal force be n1. Okay, it will not be considered since the moment is on the right hand side. Okay, we will see that later. But now currently this mass, due to this mass 2.5 kg, there will be n2 in this direction. Okay, n2 in this direction. Okay, so basically if I take a component over here, this will be equal to n2 sine theta, and in the vertically downward direction it will be equal to n2 cos theta. Okay, in the vertically downward direction it will be equal to n2 cos theta. If you see n2 sine theta is in the left hand side direction, so it is pushing, the spring will push it in the opposite direction. Let the spring force be Fs, which pushes the block in the right hand side direction, which is equal to Fs. Okay, so now let us calculate the forces for on the small block. The same n2 will be in this direction, and mg, that is 2.5 g, will be in the vertically downward direction. Okay, now we will resolve the forces. Now n2 over here, that is n2 will be equal to, as the block is sliding down, n2 will be equal to mg cos theta. M is 2.5 kg into g is 10. Cos theta is equal to 37 degree. So cos theta will be equal to 4 by 5, or cos 37 will be equal to 4 by 5. Okay, now this is the value of n2. Now what is the force that is acting on this spring in the left, or on this block in the left hand side direction? If you see, the force over here is equal to n2 sine theta. If you see, the force on the left hand side is equal to n2 sine theta. So n2 sine theta will be equal to n2, which is equal to 2.5 into 10, which is equal to 25. 25 into 4, which is equal to 100. Okay, 100 by 5, which is equal to 20. So n2 is equal to 20 over here. Sine 37 is equal to 3 by 5. So 3 by 5, 4 into 3, which is equal to 12. So the total force acting in the left hand side direction, is equal to n2 sine theta, which is equal to 12 Newton. So in order to keep this in equilibrium, the spring exerts a force on the right hand side direction, which will be equal to n2 sine theta. Fs will be equal to n2 sine theta, which will be 12 Newton. Okay, so this will be the spring force.